guys, and welcome to day 7 of trig, which is, we've learned a whole bunch of stuff about ratios and angle inputs and rotations and converting to radian. Now it's time to learn how to graph the basic sine and cosine curve. And essentially, we already know where all the values for these curves come from because they're actually all in the unit circle. So one quick thing about the unit circle, we need to remember that it comes from the equation x squared plus y squared equals 0, where your center is 0, 0, and your radius is 1. So thinking back about this, x squared plus y squared they must equal 1. That means that x squared and y squared, just like the two legs of a triangle, must be less than 1, okay? Or, excuse me, negative 1, because when you square it, the negatives go away. Anyway, and we also have learned previously that x is really cosine, and sine is really the y, the change in the y direction. So if we first look at sine, sine's like the first one we always look at. And of course, we'll look at it in function notation. Another thing too is that when you use your graphing calculator for trig, make sure you are in radian mode. If you put it in degree mode, it will look like a big flat line. You want it to make sure that it's in radian mode. So, mode, again, make sure it's down here, and it's in radian mode. Okay, so essentially, okay, second quit, y equals. Now, in order to graph on your graphing calculator, real quick, we'll get a preview of what we're going to be doing. You want to push sine right here, and then x. Okay, it's in radian mode, so it will produce radian in your graph. So push graph up here, and we're going to graph this guy. Specifically, we're only going to graph between here and there, so one complete cycle of sine, and I'll show you what I mean by one cycle. One cycle, like you were looking at the unit circle, one cycle is going from 0 degrees all the way around. I should do it like this, right? Positive rotation all the way around until I got back to 0, which is 360 degrees or 2 pi radians. So we're going to be graphing all of those values, and then essentially what's happening is you'll see that it's basically the same curve over and, oh, you can't really see that, can you? Over and over and over again. Okay, Desmos does graph in trig. So you can go ahead and try out some of these on Desmos as well if you're not super comfortable yet with the TI-84. So first let's look at sine in function notation. And what I did here was I put the radian value in, but underneath in the red, that's the degree value. And where we come up with these values is right from our unit circle. So when I look at sine being the y coordinate, sine of 0, right, 0 degrees, 0 radians is 0. So here, this is 0. That means I have a coordinate 0, 0, right here at the origin. Okay. Now, I'm going to do 30 degrees. That means like, what's this? This is 90, 45, so 30 is like right about there. Okay. So if I do pi over 6, and I look here and I say, okay, from the positive x-axis, and I rotate in a positive direction to pi over 6, my value is about 1/2. Well, it's exactly 1/2. So if this is 1, then right about here is my 1/2. And then again, I should write 1/2. Pi over 4, your 45 degree angle, is the same as sine of pi over 4, or square root of 2 over 2. And again, I get that as my angle from here increases or opens, rotates in the negative or in the positive direction, which is counterclockwise, and I'm looking for the y coordinate. Remember, cosine, sine. Okay, so I'm looking for that square root of 2 over 2. Now, square root of 2 over 2 is kind of annoying to graph. Down here, square root of 2 over 2 is about 0.7. Okay, so it's not quite, it's not quite to 0.75, but it's close enough. So then here, pi over 3, which is your 60 degrees, and again, you go to your 60 degrees or your pi over 3, and it's the y value, so radical 3 over 2. Now radical 3 over 2 is about 0.866, so we can go, it's right about here, right? Radical 3 over 2, 0.8, right there. I'm going to go with right there. Okay, kind of see somewhat of a curve happening. Sine of pi over 2, or 90 degrees, again, from your unit circle, positive x-axis, rotate open 90 degrees. The y value is our sine value, so the sine of 90, or the sine of pi over 2, is 1. So this kind of becomes the peak, pi over 2, 1 of our curve. Now, what you have seen so far in the unit circle, and when you've been practicing too with your special right triangles, is that you see a lot of the same numbers over and over again. So when I look first at 30, 45, 60, I get radical 3 over 2, 1/2. Radical 2 over 2, radical 2 over 2. 1/2 radical 3 over radical 2. Isn't this the same as this? Just kind of flipped. Same thing with the 1/2, right? The 45 is always going to produce equivalent lengths, right? Because it's an isosceles right triangle, right? This, if I drop that down, this side is equal to this side, right? That's a terrible right triangle drawing. I don't know if I can live with that. But anyway, so, and then from there, essentially, it's a whole bunch of reflections over the y-axis and the x-axis. So if you think about it, everything here is reflected over. And what do you do when you reflect over the y-axis? The only thing you do, this point becomes this point, is you negate the x value. That's the only thing you do. Notice these coordinates are exactly the same. Why? Because this triangle and this triangle are exactly the same. They're just in a different spot. They both have a 60-degree reference angle, right? 120 is 60 degrees from 180. We go to the closest x-axis. This is a 60-degree reference angle, 60-degree reference angle. This is a 30, 60, 90 triangle. 30, 60, 90 triangle. I'm going to produce the same ratios. The only thing that's different is the position or the quadrant that it lands in. So all of my cosine values or my x values in the second quadrant will all be negative. Why? Because negatives just mean direction. It's telling us to go to the left. Okay, so that's my mini tangent. I know you guys have missed those. Kidding. Okay, so essentially, what are we going to do? We're going to be reflecting. Oh, you can't see that. It stinks. All of those values down. All right. So 2 pi over 3, which is 120, is square root of 3 over 2. Right? That's 120 degrees. That's roughly about right there. Just going to go halfway. And that's, again, 0.866, because, again, we're looking at the y value. So it should be pretty close with that one, right? There's that reflection from the first quadrant to the second quadrant. Can you imagine that your next position is going to be that 0.7 down here? Oh, I can slide up and you guys can see all that. Awesome. Okay, so here, 3 pi over 4, which is 135 degrees. Again, it has the same reference angle as 45. It's just in another quadrant, which means initially I went to the left. And that is square root of 2 over 2. And since sine talks directly about the vertical change, right, my sine will be the same as pi over 4. So I end up with, this is halfway, because that's 90, so that's 135, right? That's right there, and then that's 180. So it's right about here. I'm trying to make it look as pretty as possible. And then, and what do we got here? Well, sine of 5 pi over 6, I'm pretty sure that's 150. Oh, it is. Look, I wrote it in red. Clever. And 150 has the same reference angle as 30, which means it's going to produce the same y direction, just in a different quadrant. And what is that, 1/2? Yeah, 1/2, we don't need a key for that. And there you go. And that's the first half, essentially, because what happens when I get to 180, right? The sine of 180 is, or sine of pi is 0 again, right? We're over here. Sine is the y position. Trig is so awesome. And I get right there. And then, knowing the behavior that this goes up and then comes back down, but again, think about the patterns that are created within the unit circle. I can literally take all of these coordinates, right, in this quadrant. Let's use this thing. Okay. Take all of these coordinates, right? If I flip them over the y-axis, all I do is negate the x values, right? Well, think about it this way now. If I'm in the second quadrant and I reflect over the x-axis, I just changed from up to down, right? So I'm changing the orientation. Instead of going up, I'm going down. That means you just negate the y values. Check that out. This point corresponds to this point, and the only thing that's different here is that the y value is now negative. That's it. Think about it too. I mean, you've got the same reference angle, it's just going in a different direction. So, pattern recognition in trig is really helpful, and I'll post some supplemental videos for you guys about that. Not required, of course, but still always beneficial. So what do we got? 7 pi over 6, that is 210. And 210, I look over here, come all the way around to 210, negative 1/2. Negative 1/2 makes sense. I'm anticipating all of these values to be negative. And right about there. And negative, it's 1, so that's negative 1/2. Okay, and then that one's going to be our 5 pi over 4, or 225. It's halfway between pi and 3 pi over 2. And going along with the pattern, again, we start from 0, go all the way around, negative square root of 2 over 2. And that's roughly about 0.7. So if this is 0.75, it's just shy. Okay, and then again, 4 pi over 3, that's your 240 from the unit circle, from 0, 0, all the way around to my 240. Looking at this here, the y position at 240 is negative radical 3 over 2. Negative radical 3 over 2 is negative 0.87, right? Negative, right about there, 0.87. Where did I put this one? Kind of like here-ish, right? All right, and then 3 pi over 2, 270, right? And sine, that's one of our quadrantal angles. Make sure I write that down. Quadrantal Google that. If I spelled that wrong, let me know. It's a quadrantal angle. Quadrant meaning 4 quadrants of 360 degrees, meaning they're multiples of 90. You've got your 90, you've got your 180, you've got your 270, and your 0 or your 360. And that's because they make the boundaries of the quadrants. They are not in any one quadrant. They create the boundaries for those quadrants. So we call those quadrantal angles. And let me see, 3 pi over 2, that's negative 1. Sorry, trying not to make your video too long. So negative 1 here, right, from 0, positive rotation all the way around, brings us to negative 1. That's easy to graph. And then we have that last quadrant to do. And that's 5 pi over 3. 5 pi over 3 being 300 degrees. Again, from here, all the way around, negative square roots of 3 over 2. And that's roughly negative 0.87. So it's going to be about here, there, yeah, it's there. Okay, and what do we got? 7 pi over 4 is a 45-degree reference angle. Negative square root of 2 over 2, right? Negative square root of 2 over 2, and that's about 0.7, but it's negative. So it's like right there. And the last one I have listed here, but it's actually not the last one we're going to graph. 11 pi over 6, that's your 330. 330, I believe that's negative 1/2. And let's just double check my math. It is negative 1/2. So right about there. Now, when we graph this, what's important to remember is 1 full cycle actually lands onto pi, and 2 pi is the same angle as the one we started with, as sine of 0, right? Those are coterminal. Coterminal angles, right? 0 and 2 pi all the way around. That was weird. But anyway, so we would end right there. That's what we call 1 full cycle. 1 full cycle means I went through all of the 360 degrees, or the 0 to 2 pi radians, and I've completed 1 full cycle of sine. Now, sine essentially, you can think of it too as, oh, that's terrible. But anyway, you can think of it too. Notice that it does not go below negative 1, right? And it also does not go above positive 1. It will bounce back and forth. The big thing too is a pattern that we see all the time in the sine curve is it goes 0, 1, 0, 1, 0, negative 1, 0, right? Those are right on your quadrantal angles. So you go angle, slash 0 again, 0, 1, 0, negative 1, 0. Right, it's kind of like this oscillating relationship, which is really cool. And that is essentially sine. Now, for your homework, it's a 2-parter, I'm sorry. I do want you, for your homework, I'll write this in pen here, for your homework, I want you to graph the cosine curve for me. Okay, just one graph of cosine, that's all you got to do. And then also, so that's task number 1, and then also complete the 5 delta math questions. Now, I will give you a heads up on the Delta Math questions. They are more of a preview, what we call discovery of manipulations that we're going to be playing with the cosine and sine curve. Because once you've graphed it, I mean, you've graphed it. So again, two-part homeworks. I want you to graph the cosine theta or equals f of x. Just one cycle. One cycle is totally fine. If you don't have graph paper, that's fine. Just do the best you can. If you don't have a ruler, that's fine. Use the side of your phone. Use the side of a book. Use the side of a coloring book. And just do your best and make sure I can read it. I want to make sure you understand what's going on. And then two, again, the 5 Delta Math questions are questions that you're going to start to see how we're going to manipulate these graphs, okay? So just do your best, and I will also post some supplemental material that is not required, but will help you in kind of like a preview of what's going to happen next. Okay, have a great day. I miss you guys all, and I'll see you soon.